And without much further ado, really, I would like to welcome Professor Stajano from the University of Cambridge. I would just say the reason for inviting him is that he will be presenting his paper, Pico, No More Passwords. And when I saw that paper, I just read the abstract, and I really got provoked. And I thought, this is a real professor writing. It's like, yeah, passwords are bad and we should get rid of them, sure, but well, how can we do it in real life? So I'm really looking forward to this presentation, and Frank, the stage is yours.
Thank you very much. You're welcome. So it's a pleasure to be here. As Per said, please ask as many questions as you want. The paper that he read is available on the web, but it's not even the final version. I'm still writing it. I gave this talk first time in March, and the final version, post-proceedings version, is due later this month, so I'm still working on it. And look for the final version on my webpage, but more than that, interact with me today so that some of the stuff that comes out of this can also learn. So the title, Pico, No More Passwords, is motivated by something that I'm sure you have experienced as well. As a computer person, I have to be the unofficial help desk of friends and family, as I'm sure all of you do as well. And so one of the things was, okay, so you work in computers. Why do we have to do all this mess with passwords? Why is it so complicated? Can't you make this stuff simpler? You've been working in computer security and all that. And so it used to be that passwords made sense when you had one difficult password to remember, but difficult wasn't that difficult. I mean, maybe 8 characters were considered fine, and you didn't have that many passwords. And what happens now? People have plenty of things that they have to secure with passwords, and the passwords themselves have become more complicated than a regular human memory can manage. We're talking memory of normal people, not the people who obsess about memorizing 100 digits of pi and having contests about it, which I'm sure there's many of us in here. But we shouldn't use that as the standard. So the security people tell the regular humans that passwords must be unguessable and impossible to brute force. It means they cannot just be like a cat or fish, or the name of your cat or fish. They have to be long and complex and full of special characters, and they cannot be something that people can guess by looking at your Facebook page and knowing what your pets are and all that stuff. If you have many accounts, and everybody has many accounts, all the passwords that you use must be different. The passwords must be memorable, and you must actually memorize them. You're not allowed to write them down. And when you are entering them on the computer, you must type them correctly, even if they look like this and you make a mistake about here, and all you see is asterisks, and you're not sure where you can't even correct. You have to delete the whole thing and start again, and hopefully you don't make a mistake about here. And to add insult to injury, you must change the passwords every few months, because otherwise, if there's a compromise, you might expose things for years and years, so you have to keep changing the passwords. So there's reasons for scratching one's head. If you dispassionately look at all the requirements that we security people tend to give to ordinary humans, then, how can you satisfy all these things together? If each one of these is a subset of the possible passwords, the intersection is the empty set. There's no way that a password can be at the same time as complex as it should be and memorizable, and you have 37 different ones of them, and you change them every few months, and so on and so on. So there's several burdens that we are imposing on users. One of inventing passwords that actually match all these requirements. Then once you've invented a good password, you have the burden of remembering it or them. And then even if you can remember that password, there's the non-trivial burden also of entering it in the computer. So all these three things that we are imposing on users are actually beyond feasibility. There's a wonderful paper on the usability of security systems by the group from Angela Sasse in London, which talks about the compliance budget. Has anybody heard of the compliance budget. No, okay, so if that's news to you, you should read this paper. It says, basically, there's people are willing to follow the rules of the system administrators, but every time the system administrators ask for something, it's a bit of a nuisance. Okay, so there's a kind of, up to a point, I will follow these rules, and after that, it's just going to be too much, right? So the more burden that is imposed, and the quicker this budget is reached, and once you are at the end of this budget, then the user is going to stop complying with the rules, just trying to bypass them in every possible way. So we are spending quite a lot of the budget, compliance budget of the users with all this. The trouble is that for people who, let's say, impose or deploy the password, so for example, someone who's a web developer and makes a new application says, okay, now I have to distinguish between my users, so I have to do something to secure the accounts, and what I'm going to do, I'll set a password. That's the obvious thing to do, because in every other web account, the user has a password. They already know how it works. I don't have to explain anything. It's an obvious thing. It doesn't cost anything to issue a new password. And for me, it's the cheapest and easiest thing to deploy. And it can't be that bad because everybody else is also doing it, right? So this is what economists call a tragedy of the commons. Has anybody heard this term before? Tragedy of the commons? Yeah, okay. So for those who haven't, the tragedy of the commons is like a common piece of grass where you can bring your cow and sheep to graze, okay, and it just belongs to the village as a whole. It doesn't belong to anyone in particular, so you can just bring your cows and they're going to be fine. But there's only a finite number of cows that can comfortably graze in these commons. And if you bring twice as many cows, then none of the cows are going to have enough to eat and be comfortable and so on. So you shouldn't overgraze, otherwise it's bad for everybody. But if you're just one farmer and the commons are there and you say, well, this has reached capacity, but I have 2 more cows. Why don't I just bring my 2 extra cows? Nobody's going to notice. It's going to be the same. And the benefit for me is I feed all my cows. And it's not a big deal for everybody else. And if everybody does that, then there's 2, 3 more times cows than the commons sustain, and then it becomes a mess. And this is exactly what happens. Every web developer says, well, what's my password going to do? That's bad, and because everybody else is doing it, and so this just doesn't work. And so even though web developers consider the passwords to be the cheapest option for user authentication, users hate passwords, and they have good reason for hating passwords. So passwords are dead, has been said many times. Passwords are not dead. Actually, passwords just should be dead. And what we saw in the previous slide was just they should be dead on usability grounds. They should also be dead on security grounds, of course, because first of all, the fact that the requirements that we had in the previous slides are impossible to satisfy simultaneously means that some of them will not be satisfied. Even if you have a user who's willing to comply, they cannot comply with all of them simultaneously, so they're going to drop 1 or 2. You can't predict which ones. Depending which ones you drop, you have insecurity. So if they drop the requirement of making the password very long and complex and full of crap, then you're going to have a weak password. A weak password can be guessed or can be brute forced. You can have users dropping the requirement of having a different one for every account. This is very common occurrence. And if passwords are reused, then it's sufficient that a password is broken at one site, and then the other sites can also be attacked, or a password is leaked at one site without even being cracked, or there is a malicious insider at one site. All these things will cause all the other sites where this password is reused to be compromised. And then because the password system is too complicated to actually work, then users will sometimes forget the passwords, and the system providers have to cater for that with ways of recovering, and they have these questions like, which high school you went to, and what's your mother's maiden name, and all that, and sometimes it's much easier to get in that way than by cracking the password. So just the fact that the burden of remembered passwords cannot be met, you can get in through the recovery mechanism, Sarah Palin customer. And then of course there's a fact, if you cannot remember the password, it can be then written down somewhere. It's unlikely that it's going to be written down in a way that is impossible to get that from someone else who's there, so that's another avenue for getting through. Besides attacks that are enabled by the fact that the previous requirements are impossible to meet altogether, there's other things that passwords are susceptible to, and one of them is phishing, where another site puts up a front that looks like the site where the user is trained to type the password, and then the user types the password in the other site, and then the bad guy gets it. And this is just one automated form of social engineering, and there are, of course, several others that tricks that the bad guys can use to persuade the unsuspecting users to part with their password. And then there's keylogging, which is similar but in a different category, where there's a piece of malicious software on your computer that watches every keystroke. And if you are typing a password, even if it's a very complicated password, even if it's a very long password that nobody could crack, the keylogger just records every keystroke, and you're done. So there's a famous quote from Bill Gates from 2004. There is no doubt that over time people are going to rely less and less on passwords. People use the same password on different systems, they write them down, and they just don't meet the challenge for in this case it's passwords, don't meet the challenge for anything you really want to secure. So passwords should be dead, even though they are not dead quite yet, unfortunately. So the question here is, what if we could start again from scratch? I realize we can't start again from scratch. This is what Eric was exactly. You can't do that. It's impossible. It's never going to work. That's true. Okay, it's never going to work. But what if we could restart from scratch? What would we do? What is the best possible thing that we could do instead of passwords? Passwords are no good. We may be stuck with them for compatibility shackles. What if we didn't have those shackles? Could we come up with anything better? So this is the space where I'm at with this talk. And there have been many interesting proposals for fixing passwords, or getting rid of passwords, or doing something better than passwords, especially on the web. Now, on the web, it makes sense to do this on the web. First of all, because the web is responsible for the proliferation of passwords that we've had over the past decade. Before the web, there weren't that many things that ordinary users, like your greengrocer, had to authenticate to. And second, because with the web, you have a uniform interface. Everything looks the same. Everything looks like something that can be rendered by your browser. So it's fairly easy to develop a solution that will work for across many sites. However, for the user, for the non-technical, non-computer user, it's really not enough to say, well, I'll fix the passwords for the web, and every other password still have to type the password and still follow all these bullshit requirements that we said earlier. For a user, a password is a password. If a password is a nuisance, it's a nuisance, whether it's a web password or a login password or a file encryption password or whatever other type of password. So we have to aim at the right level, and if you're going to do a proper job, get rid of all passwords, not just the web passwords. So if I start from this standpoint, what are the minimum requirements that any solution should have? Well, first of all, if I am fed up with the fact that it's impossible to memorize passwords like that, the first thing has to be that users should not have to memorize passwords or any other thing that resembles passwords. Some people have made things that are not passwords made of letters, but passwords made of squigglies, or passwords made of, remembering faces of other pictures or stuff like that. So, first point, users should not have to memorize secrets. That's for catering to the usability. That's not the only usability point. I showed many others, but that's the minimum. For security, whatever replacement we come up with should be at least as secure as passwords. And here I mean as secure as the passwords would be if we could make them work, given that, from what I said, it's obvious that passwords are insecure because the requirements that we ask for cannot be met. If they could be met, we want something that would be as secure as that. And then, because we've seen that one of the failure of passwords came about because we went from just having one or two to having dozens of them, this new method should be scaled even to thousands of applications. It is a fact that we are going to interact with more and more computer systems that will not necessarily look like computers. They will not look like this. They may look like everyday objects, ubiquitous computing, all that kind of stuff. Imagine authenticating to each one of them with a password is a non-starter. So for scalability, the new method should work with thousands of apps. Now I use the term apps here and in the paper as a redefined word to mean anything that asks you to authenticate to it. So the app is the verifier. It's not app in the sense of the stuff you install on your smartphone. The app is the thing that would ask you for a password. Because the system I'm going to propose relies on a token, and so the password, what you know, becomes the token, what you have, then for any solution that uses a token, you also have these other essential requirements. First of all, that if you lose the token, you can still get at all your accounts. It's not like your life ends there and you have to restart from when you were 2 years old. And second one, if you lose the token or someone steals the token, then they can't get at you. It's not like the token is instant recipe for identity theft. It should be that just possession of the token is not enough to impersonate. So, the 0 point something were minimum requirements any solution should have. The 1 point something are things that I claim that my solution offers, claims that what Pico does. And you are most welcome to challenge me and say, you promised that you would provide that, but actually I don't think your solution is offering that. So first of all, the user no longer has to remember the password. That's the same as 0.0 before. Another essential thing, it works for all credentials, not just the web passwords. And one problem is that users choose weak passwords with the Pico system, which is a handheld token. With the Pico system, the Pico chooses the password. It doesn't even use passwords, actually. It chooses a credential for you, so it's impossible to make a weak one. Another problem of passwords is that users reuse them. You reuse the same one on different sites, and with Pico this cannot happen either. Phishing is also impossible because of a recognition between the app, the verifier, and the Pico. This is something that in some cases you do with passwords when you have some kind of SSL machinery, for example. You have to make sure that anything that is not recognized is refused. Another problem, which is related to phishing, but it's also related to usability, is that one thing we fix with Pico is that the user does not have to select the correct credentials. Imagine that you had a token that knew all your passwords, and like a kind of password wallet, these things exist for EDMs and things like that. This says, I mean, the screen I have here, which is not reproduced here, says, welcome to MNAUD 12 blah 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 at the client username and password. If I had this list with all my maybe 100 passwords, I could pick the one that matches that, and I would know which username and password it is, and then I would have to type them in. And I could be tricked into selecting the wrong credentials. Being tricked is related to phishing, but also having to select this is a burden. If I have that many, I mean, I can have a hierarchically arranged list and so on, but it's so much better if the Pico decides on its own which one is the appropriate credential for the app that I'm interacting with. Network eavesdropping of the password is impossible in this system. This is something that some password systems do. It depends on how the password is transmitted to the verifier, but sadly still not all of them. Keylogging, which is a kind of local on the machine eavesdropping, is also impossible. And related to that, but separate and actually more relevant to usability, is that the user no longer has to type that password, which is a nuisance. in and of itself. So obviously, if you don't have to type the password, then you can't be keylogged. But you can still have things that avoid keylogging. For example, you attach a USB cable and it pretends to be a keyboard and types the password, and that could still be keylogged. So it's, in that sense, 1.8 is distinct from 1.7. A totally independent and interesting aspect of using Pico is that authentication happens continuously, not at the session start only. So when you type in a password, for example, to unlock your screensaver, then the resources of your computer are available to you because you have just proved you're there by typing the password. Then if you go out and get another one of these swirly things, maybe you see, okay, well, I might also just go to the toilet, and you're out for maybe 10 minutes and your computer is there and you haven't re-enabled the screensaver. It still thinks that it's you because you just typed in the password for the screensaver earlier. So unless you have a very short timeout for your screensaver, you're going to have a window in which the guy who was sitting next to you can still see what you had, check your emails, whatever, before you come back. If you have a very narrow window, then you're going to be bothered very frequently by the screensaver going on and you having to retype the password. So with the Pico, authentication happens continuously. And so you can say at sub-minute intervals, the app verifies that you are still there. And as soon as you're not there, it can lock the assets. And as soon as you're back there, it can unlock them. And this is something that is a great addition, feature both for usability and for security. And finally, the user can authenticate from any client. This is not a solution that is specific to just one particular machine. Now, to this list, some people might expect I would have to add, okay, it's going to be as cheap to deploy as passwords, and it can be deployed without changing the verifiers. These are things that I decide are not goals for the Pico, because I want to be free from these compatibility constraints in order to design a proper solution. Now, this is not to demean them. Of course, without these, it's going to be difficult to displace passwords. So later on, we may think of ways to compromise on some of the design principles so that we would provide something in that direction, with the proviso that, of course, that's not where I want to go, but we have to start somewhere in order to break the vicious circle of, oh, it's not going to work because passwords are still entrenched in a way that is undisplaceable. So this is the plan for the talk. First, what Pico promises, that was the previous slide. Second, how Pico works. And because Pico is a token, and if you lose the token, it shouldn't be something other people can use in your stead, how Pico ensures it won't work if you don't have it. And conversely, how Pico ensures that you can recover yourself if you no longer have it. Some special features of Pico. Then a comparison with work by others, both work that exists and work that doesn't exist. I mean, real-world things and academic kind of stuff that has been described in the same way as Pico. I mean, Pico doesn't exist yet. I hope that some students will want to build parts of it with me, but it's not there. And so comparison with both of these types. And as I just said, examination of some possible compromises to reach critical mass. And finally, a roadmap to the world domination, or rather world liberation from passwords. So let's start with how Pico works. How Pico works. Imagine that a Pico is something the shape and size of a smartphone, although it doesn't have to be that. And it would have at least the following components. It would have a camera here, display, and two main buttons. Okay, one button is for pairing. It's like setting up a password. And the main button is for like typing the password. We are not using passwords, but just think of these familiar things. So the Pico is small, it's something you carry all the time, like your phone, like your keys, like your credit card. And it has a radio communication facility, it has a camera, and it has these two buttons and a display. Having said that, it doesn't have to be the shape I showed before. It could be a number of other shapes, so long as it has these minimum features. It could be like a key fob, it could be like a watch, it could be like one of these tiny MP3 players, it could be a piece of jewelry. If you're willing to wear something like this on your ear, it could be an earring. The buttons could be soft buttons that you press on the screen, whatever. So we are not interested in the industrial design quite yet. So how Pico works. The place where the app, the verifier, asks for a user ID and password is complemented by a visual code. And this visual code is what gets acquired by the Pico through its camera. Also, the Pico has a short-range radio facility to communicate. So we have two channels. In the past, I have done quite a bit of work with some of my former students on multi-channel security protocols. Security protocols where you use several channels simultaneously to send different messages of the protocol because different channels have different properties. So the property of this visual channel, first of all, it's a unidirectional channel. It only goes in the direction from the app to the Pico. There is no visual channel from the Pico to the app. It has a very useful security feature, which is that the user knows for sure what the other endpoint is. This is not the case for radio. With radio, if I'm talking to something, the other end will tell me its identity, but I cannot be sure that it's not some other piece of radio that is saying, that is pretending to be this computer, and it's actually under the desk here somewhere. And so I'm thinking that I'm talking to PC2, and it says, yeah, I'm PC2, okay, right. But actually it's something coming out of here. Whereas with the visual channel, if PC2 is displaying the code and I'm acquiring that code, then it cannot be the code that comes from another one. So that's an important feature of the visual channel. However, the visual channel has a limited capacity as well as being unidirectional. And so we were saying earlier, it cannot just carry a whole 4K public key. It can maybe carry the fingerprint, whereas the whole public key could go over the radio channel, which doesn't have these capacity constraints. And the radio channel is also bidirectional. So I use both in the protocol for different purposes. So each app in the Pico system has a public key pair and a visual code, and the visual code is basically a certificate on the public key. I have a picture here where, okay, this is a self-signed public key certificate, whatever metadata is necessary, the name, the human readable name of the app, and then the public key of the app. This is signed by the security of the app, and then hashed, and this is what is in this visual code, which is acquired over a visual channel, whereas this other thing, including the full public key and blah, 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 is sent over the radio channel. So as I just said earlier, the visual channel is there so that the user explicitly designates the chosen verifier. It cannot be mistaken from another fake one over radio. And then over radio they get all the data that is required, and also they can talk back. So winding back by one, the app self-certifies its own public key. The Pico acquires the visual code of the chosen app and talks to the app by radio. Once it has got the public key and verified that the public key matches the visual code, it can send everything, all messages to the app encrypted under that public key, meaning that no other malicious impersonator can actually read that traffic, assuming that the app has good control of its secret key. So this defeats the eavesdroppers, was one of my claims. And the user cannot be tricked to type the password into the wrong app. I could type the passwords in quotes because I'm not typing any passwords anyway, but cannot be tricked into revealing credentials to the wrong app, because the only app it's talking to, it's the one that has the secret key that matches the public key, and the public key is identified as the one that was displayed by the genuine app. So this all looks very much like SSL. In fact, the mechanics are essentially the same as SSL, but the fundamental difference is that SSL relies on a PKI and a public key infrastructure to certify the public keys of the verifiers, and in this case we don't have the public key infrastructure, things are just self-signed. So the app shows its front page with a visual code like this, and whenever the front page is available, then two actions are available to the Pico. One of them is, so I'm here, the normal one would be enter your credentials and log in or access or whatever it means. But the other one that's also available from this state of the interface is to create a new account, if that's an account or whatever else. And so this is done on the Pico with the two distinct buttons. So the main button is the one that says, recognize me, let me log in, let me offer my credentials. And the parent button is the one that means, okay, I want to make a new account for myself, a new pairing between my Pico and this app. And so let's have introductions. Let me create an account. Let's do the initial pairing. So the main button, the one that I use when I already have a pairing with the app, works like this. The user of the Pico aligns the camera to acquire the code of the desired app. And this is the hash of the public key certificate. The certificate and public key themselves go over radio, can be verified with what was acquired over the visual. And then, because I have already paired with this app, as Pico, I will have a number of slots, and in one of these slots there will be the one corresponding to this specific app, which I find by the public key. If the app was not among the ones that I knew, then I cannot do this and I will stop. And stopping at this point can be paired in the interface to the user with a phishing warning, because if you think you want to interact with this app and you press the main button saying log me in because I think I can log into this, but you can't, your Pico says you can't, then it means you are interacting with something that looks like something you thought you had an account with, but you don't. So maybe this is a fake. So this would be a good stage to give you a potential phishing warning. Because anything that pretends to be the real app but doesn't match the one that you have in there should not look like one that you think you already have. So anyway, assuming that instead this step goes well and it continues, then the Pico will send an ephemeral public key to the app. And the reason why it's an ephemeral public key as opposed to a long-term public key is so that you are protecting the privacy of the user. Because at this stage, the app has not yet proved to the Pico that it knows the secret key of the private key it is exhibiting. Are you still with me? Is anybody lost? If you're lost, hands up. Okay. So, because the app hasn't told me that it knows the secret key of its public key, then I don't want to reveal which user I really am until I know I'm talking to the right app. So that's why I'm just sending an ephemeral public key. And then I, Pico, challenge the app to prove the ownership of the app's secret key with some challenge response that uses the app's secret key. And once they do prove to me, oh yes, okay, I have the secret key as well, then I can send them my long-term identity. So if this is an impersonator, they won't even learn that I was there, because they only get a temporary ephemeral public key. And then I send them my long-term public key that's going to be the other side of the mutual authentication. The app challenges the Pico to prove ownership of the Pico's account secret key, and that's that. And from then on, they have both proved to each other that they are who they say they are and they have the secret key. They can set up a session key and then start the continuous authentication I was talking about, where through the radio, yes.
I have a question. Does this mean you don't have any anonymity anymore? Because if you give your own public key to them, different sites could compare the keys and match you as a single user.
Yes, so you are raising a good point. I am happy that you are asking the question if this was unclear, but I want to reassure you that this design is specifically to ensure that you are as anonymous as you can possibly be with this, because you have a different public key for every account. So in this slot, I store the public key of the app, and next to it will be my own public and private key pair for that particular app. So for each account, I have my own pair. And in fact, even with the same app, with the same verifier, for the sake of example, Gmail, okay? I can have 3 Gmail accounts. Each one of them will have its own different credentials. And Gmail itself would not be able to link those together unless I do something at the application level, okay? So precisely for preserving my my privacy, I am giving an ephemeral public key at this stage when I'm not sure that I'm talking to the right verifier, instead of my long-term public key. But when I said long-term public key, I meant the long-term public key for that particular account. So even then, they would have only been able to know that I was that guy that had been seen before for that app, but not linking to the ones from other apps. Okay? So what happens with the pairing button? So I don't, I want to create a new account with this app. Maybe I don't have one at all, or maybe I have one and I want to create another one. I start from the same state for the app, the same initial screen, and I just press a different button on my Pico. Acquiring the visual code is the same as before. If the app is known, then I may get a warning. Are you sure you want to make a new account? You already have one for this, but you're allowed to make one, so long as the app doesn't forbid this, and in fact, you shouldn't be able to tell. Then repairing a second time is still allowed. Now, I have to put in a little footnote here that if I do have multiple accounts, then one of my original claims is not going to be 100% fulfilled, where I said that the user no longer has to select the credentials because they are picked depending on the app. Well, that is true in the sense that the Pico will know that I'm interacting with this app rather than this app, but if I have several accounts with the same app, then of course there will have to be some kind of disambiguation as to say which one of your accounts with this particular app you want to use this time. So that can't be helped. I mean, there's no theoretical way that you could select automatically if you have several ones to choose from. So as before, the Pico gets the full key of the app through the radio, checks against the visual code. Then now it stores it in this slot, I should be more precise. It stores it temporarily until it has verified that the app also has control of the corresponding secret key. It does the same trick as before for protecting the Pico's privacy. And then the Pico makes its own key pair for that account. This may have been pre-complete if the Pico is too slow a processor to do that on the fly. That's just an engineering detail. And it sends the app this long-term public key for that account. As we were saying, it's specific to that particular account. And this basically allows the app to make a corresponding slot in itself where it stores the credentials for this user, which will be the public key of that Pico for that account. And if we need to have a user ID for the user to identify itself with the app, then this can be defined through the normal user interface on the computer that would be used for defining the user ID, and then stored in that same slot. So I am trying to make the Pico something that you have to do as little interaction with as possible. So I wouldn't like to have to type in a user ID on the Pico or something like that. You can still do all the normal things with the keyboard on your normal computer and just use the Pico for this crucial authentication part. Now, this is fine for something where creating an account has no previous state, as in opening up a new email account with a free email provider. If you are creating an account which has to be linked with some real-world resources, then there's another step for authenticating this binding. So if, for example, I am setting up an online banking account, and I already have a bank account with that bank, then I have some money somewhere, and when I create a new online identity here, then the bank, I expect the bank to link that to the money that I have deposited, so that I can then use this to do online banking there. So there has to be some binding between this thing that I am doing here with the Pico, which is completely coming out of nowhere, and this thing that I have done previously with the bank. So this binding is done with another channel, which is neither the radio or the visual. It's the bank sending me, for example, by post or by me going to the branch or whatever, sending me some other authenticator, which could take the shape of a paper letter just to interact with the camera mechanism that the Pico has. And then what would happen is that the back end of the bank sent a letter to the user with a special once only authenticator, which says, when you're going to pair up and create your new account with us, then you have to exhibit an authenticator, which is this visual code I'm giving you now. And so you would use the Pico to say, okay, here's the letter from the bank, let's acquire this code and spit it out when you see this public key. So there would be one code, which is the authenticator, the one only nonce that has to be shown to the bank to prove that you got that letter. Another one that says, this is the public key to which you have to send this, don't send it to anybody else. So you put that in your Pico, and then you do this creation and you say, now here comes the authenticator that I got from you in the post. And then the bank is there and says, oh, okay, now I can link that to the actual back-end money account resources that are associated with this user. And so at this stage, the app records in its backend that the Pico's credentials are valid, and from then on, you interact as in the previous slide, just like that with the main. So that's how Pico works. What am I doing for that? And let's see how the Pico ensures that it won't work if you don't have it. Now, there's nothing really special about the Pico. It's just a glorified password wallet that you hold in your hand, except it doesn't use passwords. Okay, it's a bit smarter. It doesn't use passwords. It uses public key instead of passwords and so on. But it's basically a token that holds your credentials. Now, there have been other proposals of token that hold your credentials. What do you do when you lose this token? You must make sure that others cannot use your token. So the traditional thing has been, okay, in that case, you have to enter a PIN in the token. I said, but I'm violating my 0.0 requirement here. You know, user have to type the PIN, that choose 1, 2, 3, 4, and all that kind of stuff. So let's see if we can do something without relying again on a secret that you have to type into your gadget. Also, I want to offer this continuous authentication, which is not compatible with just typing in a PIN, because I could still type the PIN and then leave the thing on the desk or something. So, how can we secure something you have as opposed to something you know? It's unacceptable if the mere physical possession of the Pico meant control of all the credentials. And of course, this implies we need some tamper resistance of the Pico, because if the Pico is found and there is some kind of locking mechanism that someone can open it up, depackage the chip, put it under the microscope. There's a colleague of mine who is a specialist in that at the University of Cambridge. They can get all the secrets out of the Pico, then it's not so good. So of course this is necessary, having some kind of protection. But from a design viewpoint, an even harder question is, assuming that we can provide a sufficient level of tamper resistance of the hardware, how can I decide when to lock and when to unlock the Pico. What is going to trigger that? And so the answer for Pico is to have family feelings. The Pico has many Pico siblings, which are other little electronic gadgets, and when the Pico finds itself near its family, it feels happy and it's unlocked, and when the family is away, then it feels unsafe and locks itself. So these siblings could be any kind of small gadgets embedding some electronics. Imagine RFID tags, maybe slightly smarter than the essential just price tag or RFIDs, but not that much. And they could be even smaller than the Pico itself, could be embedded in all kinds of everyday objects. And the crucial thing is to embed them in things that you are likely to have on you all the time. So it could be nose piercing, it could be an ear piercing, it could be your watch, it could be your cell phone, it could be your belt, something fashionable, your wallet. And here, I mean, this is the image of the Pico, and this is other things you wear, and the shapes can change. I mean, your watch could instead have the Pico, and the sibling could be the ring or something else. If you are in a different age range, then instead of your piercing, it could be your wig or your dentures, or you choose whatever. Something that you are likely to have several of with you all the time. And these would be part of a K out of N secret sharing mechanism, where you have to have at least K shares in order to reconstruct the secret that will unlock the Pico. And it's debatable whether the K should be equal to N, so N out of N secret sharing, that if even just one misses, then you can't unlock, or whether you should have several so that you can, for example, one day have one type of earring, another day have another type, and so long as there's at least 4 of them together, then you can unlock the thing. I mean, this is all tunable design parameters. Yes?
5 minutes.
5 minutes, okay, great.
Approximately.
So let's try and finish this section now. So 2 special Pico siblings don't look like these ones. One is a biometric. So one of the K out of N shares is going to be a biometric, like, for example, an iris scan. You have a camera anyway, you might as well use the iris scan or fingerprint or whatever. All these things can be defeated in some way if the verification is unattended, but it just puts an extra hurdle to come across if someone has your Pico, and maybe, I mean, you're in the swimming pool or something where you take everything off and things are in your locker, they pick your locker, still they won't have the biometric. And then another different type of share, which is also important, is going to be a network server share. Now, this means that in order to do this authentication, the Pico needs to also talk to some server, your server, somewhere in the cloud. And this has a number of interesting properties. One of them is that you can audit when the Pico authenticates at your own servers. And another one is that if you've lost everything, they have raided your swimming pool locker, they've gone with everything, you still have a way of saying no, you disable the network server, even if they have got everything else, your Pico and Pico signals. So, well, we can finish whenever you want. I'll just go through this slide here, describing what I mostly said, talking on the previous one. The Pico's storage is, I mean, I put full disk encryption here in quotes because obviously the Pico wouldn't have a disk, but whatever storage it has is going to be encrypted. All of it is encrypted, including whatever mini operating system it has. And to unlock it, you need some secret, which is reconstructed out of this K out of N secret sharing. So most of the shares are held by the warm Pico siblings, and 2 special shares are this biometric and the network server. And these shares are pinged periodically by the Pico. So the timeouts are different for the radio ones and these other ones. So these ones may be verified, I don't know, once a day. The other ones verified maybe sub-minute. And there's a decay timer, so that I haven't heard this share for and when it goes to 0, then this share is not available. I cannot use it to recompute the K out of N secret. And I can still reacquire the share if it doesn't go away within another longer timeout, which is the case for the whole Pico. If the whole Pico has been unable to authenticate for a while, then it just switches off and you have to require everything from zero. So that's the time when you're forced to do things like getting another biometric, getting another network connection. And so this, as I said, will allow you auditing and remote disabling. So this is a kind of aside. A feature that Pico provides by doing this is coercion resistance. If you are the super paranoid type, and I'm sure we have some in the audience, then one of the threat models with passwords is that they kidnap and then they torture you until you tell them your passwords. Now, with the Pico, they can't do that. I mean, you remove the rational motive for doing that because there's nothing that you can tell them that will unlock a locked Pico if the Pico siblings are not there. So I underline that you remove the rational incentive to torture. It doesn't mean that they won't torture. They can still do that just because they like it. So if you are James Bond and you have your Pico holding your credentials to log back into M's headquarters, then when you feel you're about to be captured, you can just lose or destroy enough of your Pico siblings so that there aren't K available to reconstruct the thing. And if it's not even necessary to destroy the Pico, though of course you can do that. Maybe it's harder to destroy the Pico than just destroy the Pico siblings. You can do either or both. The security of this scheme is predicated on the existence of a safe place where you can do stuff and you're sure that in there you're not going to be kidnapped or torture or whatever it is. And in that place you have your network server, you have whatever backup we described in the next few slides, and that's it. But while you're away, I'm going to Dodgistan, and before I do that, I might decide I'm not going to use my Pico as I regularly do. I'm going to set some security features, for example, saying I will disable unlocking while I'm away from the safe place. So while it stays unlocked, fine, I can still use it. And if at any point it becomes locked, the network server is not going to respond anymore. It's just going to stay locked, whatever happens. Now, of course, this is a nuisance for availability, because if it does become locked for a genuine reason, then I can't reopen it until I go back. But if security is more important for that mission, then that ensures that nothing can be done, even if they torture you to death. Another thing that you can do is to have separate physical Picos that hold different sets of your credentials, and some of them that are really important, but you don't need on that trip. You don't need to carry them with you on that trip. So, because this is time to stop, let's have a break, and next I will tell you how Pico ensures that you can recover if you know.
15 minutes break.
I just thought of that. No,
So, welcome back.
our conversation was on.
What are we on next? We've seen how Pico works and how Pico ensures it won't work if you don't have it. How Pico ensures you can recover if you no longer have it. And like your mother always told you, do backups. Now nobody actually does that. So how can we make sure that backups are made, even if nobody ever does backups? Well, one solution I'm thinking of is to have a kind of docking station. That's the thing that recharges your Pico, and everybody recharges their cell phone. And where you recharge your Pico, it also backs it up. So this again is predicated on the existence of a safe place, where in this safe place you're not going to get screwed. You can have your backups in there and so on. So the place at home or at the headquarters of the Secret Service where you can recharge your Pico is the place where your backups are taken every time you recharge. And you have to have some kind of secure pairing between the Pico and your docking station, so that only your authorized docking station can take backups of your Pico. You don't want someone finding your Pico and putting it into a docking station and taking backup. So the secure pairing, authentication in ad hoc systems without PKI and so on is what I have been working on for over 10 years. So I am hoping that I could recycle a previous solution of mine to do this secure pairing. But I'm not discussing the pairing itself at this level. I mean, we can talk about it if you like. But there has to be some secure pairing between the Pico and the docking station. Yes?
But if the point of encrypting the data on the Pico is that you believe that the encryption is secure, shouldn't you just store it in public on the web or wherever? I mean, does it matter? As long as you sign it so you can find it again, if you have the end part of the, I assume you have to be able to.
I mean, in theory, I can encrypt all my passwords and put them on Google Docs or something, but I don't. Yes.
Oh, actually, the first thing I thought of backing it up is, if the Pico itself is tamper-proof, then the most common thought for backup is somebody's going to back it up to their PC or something, which obviously is not going to be tamper-proof, which was actually what I was thinking of asking a question about first. But yeah, the backing it up to the web that seems like an even poorer idea. So, what are you envisioning for backup, or should we just let you?
So for the backup, I envision something where, because the Pico itself is encrypted, I'm just thinking of just taking an image of the encrypted Pico. It has to be encrypted good enough so that if you lose the Pico, then you're not that worried that someone is going to undo the stuff. So in that sense, yeah, in theory, you could store this on the web as well. It's just me, I don't feel so comfortable doing that. But as from a rational viewpoint, if I trust this encryption to protect me when the Pico has been lost, that even if someone can open it up and retrieve the bits, then they won't be able to get at the credentials. Then they should be good enough for also being on the web. The fact is that when someone loses the Pico, there's only that guy who has the Pico. When it's on the web, then potentially everybody else on the web can do that. But it's just a kind of belt and braces. There's no real rational, strong argument for not putting it on the web. If you like, you can put it on the web too. The point of the tamper resistance is that even if the thing is encrypted in the Pico itself, there can be lots of other side effects of, for example, there's going to be some buffer where these things get decrypted. Does this buffer remember something about the previous versions of the bytes that it has seen, and so on and so on? Lots of analog effects, memory that retains stuff even after it's been switched off. And so for that, you still need some careful thought about the tamper-proofing of the hardware of the Pico, even if all its contents is encrypted. And so one thing that we will discuss later, but I might as well, discuss it now since we are on that topic, is what do we do for people who say, well, I'm never going to carry yet another gadget. Why don't we make this into a real cell phone? After all, it looked like a cell phone in your pictures. Why don't I put this on my iPhone or whatever it is, or Android? And the problem is that the operating system of a general purpose cell phone is just so big and complicated that you're never going to be sure if the thing you have is going to be swapped somewhere else, or if the operating system gives you all the possible access to the lowest level so that you're sure that plain text never hits the storage. You have these flash storage memories where things are written somewhere, and then the next time you overwrite it, it's actually written somewhere else for load leveling. And you want to make sure that none of this crap happens just because some other part of the OS thought it was a good idea to do that. So you want to have properly a design that is planned for storing your credentials without concern for other things that is then retrofitted to that. So it may be that a way of getting people to adopt this is to make the Pico into an application for a smartphone. That is not what I designed it as, because I don't think that this is anywhere as secure as something that's designed just to hold your credentials. So, coming back to this slide, the Pico storage is fully encrypted, so I just dump it as is in the backup. And then to restore it, I can restore a backup onto a blank Pico that I buy from the store, but I then have to unlock the Pico. So that is the way that I am trying to minimize the number of extra crypto constructions that I add on top of what I already had to have for locking and unlocking the Pico. So once your Pico is unlocked, you can create and back up new shares. This is basically creation of new Pico siblings. You can do that when your Pico is unlocked. When your Pico is locked, you cannot make other Pico siblings. And when you have a locked Pico, you have to have your Pico siblings to go back and open your backup that you just restored. I'll come back in a moment. I will just finish the sentence and take your question. And the other thing that you need to be able to back up is your Pico siblings themselves. So there needs to be some other facility, which I haven't detailed, but which is something that is a necessity in this system, so that if you do lose your Pico siblings, or if another earring is more fashionable, you want to be able to register that, that kind of management. So if I'm being honest about what I see the problems with this scheme is that all that ancillary stuff to do with the management of the Pico siblings may be the weakest point in usability terms, that users may think, well, it's much easier than having to type the damn passwords, but it's so much more complicated in terms of having to handle the Pico siblings. So yes, question.
Yes, so you can put up, you can restore an encrypted backup to the new Pico. And you can basically do that as many times as you want to. So you can have several identical Picos. Is there any way to disable an old one, say you lose it and you want to make sure that one doesn't work, since they're identical?
That's a very good point. I guess that this is something that the network server share will help you with. You could have, if you, I think that this is something that I need to think harder about, but there could be something where a combination of maybe a serial number in the Pico and the stuff that is in the thing that you have backed up can be used to distinguish the various instances from each other. And you can set your policy at the network server to say, I will now only use this particular one. And the other one, I can tell it because I'm the master. Yeah. I can tell it to disable itself. Yes, a very good question.
You talk about the K out of N for unlocking.
Yeah.
Do you see that as what you get out of that is a key, or is there some kind of sign? I mean, because the problem is, of course, for instance, RFID tags would be a very bad idea because someone would walk by and they would have your K. So
yeah, so it would have to be something where there is a protocol that runs between the Pico siblings and the Pico that is resistant to replay. Mm-hmm. Okay, so something where if you have overheard the conversation, you cannot use it to predict the next few ones, so it cannot be the same, it cannot be reconstructed from them. So it cannot just be the simple price tag RFID is what I said, because if they just say the same thing over and over again, then obviously you have no recourse to someone who listens in and replays.
So would you say that the K out of N is more of a logic policy that the Pico decides? No, I'm in contact with K out of N siblings, more than an actual secret that can be constructed?
No, well, what I think of, I mean, this is one of these things where until you actually build the implementation, you don't see all the full problem. But what I'm envisaging is that this full storage encryption of the Pico is unlocked by a key that is built as this K out of N. Mm-hmm. So as soon as the timeout says, I don't have enough to do this, then this key is deleted, and you cannot access, you cannot decrypt anything that's in the Pico, and it stops working until. So as in any real full storage encryption system, there is a part that isn't encrypted because otherwise you can't bootstrap. So that part would have to do the timeouts and stuff and say, but actually I cannot access any of the rest of the stuff because the secret to decrypt is not there anymore. And I want it to be something where it's not a gate that is opened when you see K out of N shares, but it's something that without those shares, there's no way to decrypt because the key isn't there. So it shouldn't be something that is verified, oh, you have enough credentials, I'll let you read this. It's more like there aren't enough credentials to form the decryption key. Does it make any sense?
So I'm just trying, because the idea is that you have kind of accepted that someone will steal the encrypted data.
Mhm.
That's part of the security of the system. It should still be safe.
Yeah.
And the challenge then, of course, is to get a copy of the key.
Mhm.
And I'm just trying to say, because if it is basically a 128-bit or whatever key that actually encrypts the data on the device,
Yeah.
I mean, if it's just K out of M, it seems like it would be, compared to all the security of the rest of the system, it looks like a key attack would be relatively easy.
How would you do that?
Well, as I said, because if you that's why I'm saying if you're just constructing the key out of the siblings, and it is just a static key. I mean, I kind of have difficulty seeing how you logically will actually defend against being able
Well,
to record
it's
that
not
something.
K out of N in the sense of
No.
chunks of the key, of course.
No, no.
K out of
Yeah,
N,
yeah,
proper
of
secret
course,
chain. If any of this is
of
missing,
course.
then you can
Yes,
reconstruct
yes,
other
of
stuff.
course.
And if the key can be as strong as you like, you want to make
Yeah.
256 bits key, that's fine.
Well,
So,
that's
but
not really the point.
It's not the point.
No.
But, I mean, the difficulty is, as I see it, is how easy is it to get hold of enough picosilicons?
Mhm.
And I guess the picosiblings themselves have to have enough oomph to do a mini cryptographic protocol that cannot be replayed.
Mhm.
But they also have to have enough tamper resistance that if you find one, then you cannot just open it and get its key and all that kind of stuff. And I don't presume that the user is going to rewrite new keys into the picosibling. So they will count factory program with something that you will then have to pair up to form your key with all the ones that you have. So there's going to be some management. If you want to add another sibling and make it part of the share, probably you have to re-encrypt your key, all that kind of stuff. There was another question from somewhere over here. Hmm? Yes.
I have another question regarding the siblings. Would it be possible to use the siblings to track you, for example, in the supermarket?
Oh, would it be possible to use the siblings to track me in a supermarket? So it would certainly be if the siblings always answer the same thing, right? But we said we don't want that because otherwise someone could overhear and record that and then unlock my Pico. So the protocol that we need is a challenge response protocol between the siblings and the Pico, where the responses are unpredictable. So on that basis, the things that the siblings say should be different every time. And if I am the only person in Norway carrying a Pico, then you can track me in the supermarket. But if everybody, instead of passwords, uses Picos, then you'd have continuous chattering of the various Pico siblings around people, but they would not be identifiable because they would still sound different every time. It's only if you are party to that protocol that you can verify if the sibling is the one that you expect one of your family or someone else's family.
So they're sending their identity also encrypted.
Yes, well, I must say I haven't written that protocol out, but it has to be a protocol with at least the feature that it cannot be replayed. And I imagine that if we did that, we could do something where we're also hiding the identity. Yeah.
Maybe I don't understand it correctly, but what is the security advantage over carrying multiple tokens? I mean, what is if you look at it objectively, and for me it is, if I use multiple tokens, I get the same security.
Same security as well.
Yes, that's just this system.
Well, multiple tokens scales up to 3 or 4 tokens. It will not scale to 1,000 tokens, right? And you're not going to carry a suitcase full of tokens.
Don't carry a suitcase full of earrings.
No, but the point is that the earrings, you just have to have enough earrings to unlock your Pico. You don't have to have a new earring for every account.
Yeah, and I just need enough tokens to authenticate. There might be one token in between, which is intelligent enough to, like the Pico, to store certificates and stuff, but it's multiple tokens, and and this doesn't overcome the security of multiple tokens.
I mean, I'm not sure we are on the same wavelength. This is multiple tokens. It's just that the tokens have different purposes. All the tokens except one are used to unlock the last one. And the last one is the one that stores the credentials. These other tokens don't store any credentials, don't have any user interface.
Yeah, okay.
So the difference is that the earring token is just there and talks radio, and it has to work something else so it doesn't have to have its batteries changed every day. And the only one that I interact with is the one that has this button display, whatever else. And I don't want to have earrings with a user interface, nose rings with user interface, and all that kind of stuff, dentures with user interface. And they are only there to basically make an electronic lamp around me so that the Pico knows that it's with me. But they are not used for authenticating directly. Yes?
This is something different. No, not security issue, but health issue. How healthy is it if we have all these things around us and we have a Pico that communicates? We get the radiation. So are you planning to check how much it radiates, more or less than cell phone? Because now they are doing research that cell phone are causing cancer. So I don't want to have out information.
Yeah, you're absolutely right. So, I mean, the stuff with cell phones is you need enough power to talk to something that is a few kilometers away, which is the radio itself. Right? With this thing, you have to have enough power to talk to something that's 1 meter away. So there is hope that the transmission power is going to be several orders of magnitude less than what you are already willingly carrying with you all the time. And if you are worried about the radiation, then I guess once your worries are satisfied that your cell phone is safe, whatever is done for a cell phone can be done much better for things that are much shorter range. Yes?
So the RF safety is kind of an overblown thing. In the United States, I've actually got an amateur radio license. I've gone through 4 theory tests and a few Morse code tests, and I've held the license for quite a while. Literally, if you stand in your kitchen by your microwave, you're going to receive a higher dose of any sort of RFI, EMI type interference than you will from carrying your cell phone for an entire year. The actual radiation of things like cell phones or RFID tags is completely overblown. I mean, even if, for example, if you live near power lines, you should worry about that. You shouldn't really worry about the RF from like a cell phone. Or for that matter, even just general, a concrete will give off radio frequency to a much higher degree. And the other thing was that the gentleman that was talking about tokens, I think you were referring to, you're thinking of like, say, RSA secure ID tokens?
Yeah.
Well, the problem with that though is that with that token you still need the token itself can't be your only means of authentication, because if someone had that token, then they're you. You still have to have a username or password or PIN or what have you.
Okay, but if I have the people and all the earrings and stuff, I can authenticate as well.
Sure, if someone, kidnaps you and robs your house and finds all your Pico siblings, then that's a different problem.
Well, that is one that would be addressed by having a network server. So if someone is kidnapping you and you manage to break your Pico, just drop your earring or whatever it is, and so that the Pico gets locked, they can't unlock it if your network server says, well, I was on a trip, so I'm not going to let this work here. Of course, if you were on a trip, you didn't worry so much about stuff, and you said, okay, and next day you can still unlock. They can wait until next morning and unlock. And that is all trade-offs. I mean, the paranoid stuff is not something that I say very seriously. But, I'm coming to this from trying to make things easier for people who can't stand the passwords as we impose them on them now. But I also want to explore the boundaries of this. Having said that, this is not going to be major design criteria on how to protect things from people who mug you and abduct you and torture and so on. Because, first of all, because passwords are not good against that anyway. Yes?
Because actually I think that is something I think academic security all focuses on, is that if someone kidnaps your daughter, you want to give them your password. Sometimes you don't want too much secure tamper-proofing. It is something that bureaucracy loves. You cannot steal from the bank because you work there. Well, but maybe you want to make that decision yourself. That's actually, I don't think that should. I mean, it's in.
Well, I think that
it's a good
this
selling point.
This
I don't
is a
think
very
it's
good observation, and I think that the distinction. I mean, this is just an intellectual discussion, not so much practical. The intellectual distinction here, which I think is relevant, is there a way of recovering, or is there not?
Mhm.
If you make a system where at some point there's a point of no return, I've made it so that I can't retrieve it, nobody else can retrieve it. Well, you want to torture me, you want to kill my daughter. Well, I'm very sad if you do, but even if you do, there's nothing else I can do. And at that point, that's it. If there is still the case that, with me here, I can do nothing to help you, but at home I have a backup, which if you let me free, I could go and retrieve, then of course you're still under threat of, I'll do stuff so long as you then go and go back to your home and redo whatever else needs to be done. So I guess the predicate there would be if you let me go back home and it has to be only me because biometric and so on. By the time I get back home, I can have all my support and have machine guns against you. But intellectually, the only difference is between whether anyone can recover or nobody can recover. If nobody can recover, then, I mean, again, there's no rational incentive to torture you or your dear ones, but they can still do things. Yes?
If someone, for example, pickpocketed you and took your Pico, and then walked right behind you to receive the Pico siblings, wouldn't they then be able to identify with varying stations?
I guess so, yes. So if they steal my Pico and I don't notice, and I'm still around within range of the Pico, then they could still use it to authenticate. They'd have to keep following me with a laptop behind. It's not going to be a long-range thing. Now, another thing that we have to worry about for this kind of radio authentication is relay attacks. So in our group, in Cambridge, we did done quite a bit of work on relay attacks. Relay attacks is where you have a radio token, for example, something that opens a door. And as I go in, I don't have to do an interaction with a specific reader, just because near here, it radio senses me and it opens this door. So there's a prover is the thing I have in my wallet and verifier is the door. Now someone sitting next to me in the cafeteria could have something that looks like a door, electronic, next to my chair, and then they send with their cell phone or something the signal. They relay the challenge response to some accomplice who is there with something that looks like my token next to the real door. And then the door challenges the fake token, which is sent by cell phone to the guy sitting next to me in the cafeteria. And this challenge is relayed to my pocket. And I don't know that I'm being challenged, but it answered with the correct response. And this is sent back, correct response is sent back there. And then this opens the door for the bad guy who gets in. So relay attack is a problem in this case. And the solutions to relay attacks involve typically elaborate protocols that do a time delay, so that, because the speed of light is finite, you cannot be any further away than that if you have taken not more than that. And so with this kind of mechanisms, for which my colleague Marcus Kuhn has developed a specific RFID protocol, then it is possible to limit the relay attack to something that is very close to you. In which case you hope that you might spot it, you might still not. Yes?
Did you say anything about backup of the Pico's siblings? Because you did say that your glasses would be fabricated with this thing inside it. But if you break, say, 3 of your 7 items, then your Pico would be locked forever.
Yeah.
So if the items are prefabricated and can't be written to, how do you then take backup and restore?
Yeah. So this is what I said here 5 minutes ago, that there's going to be some mess to do with the backing up of the Pico and also of the creation, addition, and key management and backing up of the shares themselves. And I am a bit afraid that this is going to be the weak point of this Pico system, that this is going to be the thing where the usability gets out of control for regular users. Management of these additional shares, making sure you can't get locked out, that you can decide that this earring is no longer fashionable, so you want to unregister and register a new one, that kind of stuff. So necessarily something that needs specific protocols and specific usability attention. I haven't solved that problem yet. Yes.
I was wondering, you started this with the presentation of your paper as a sort of, if we could go away from passwords. And this is a very specific design, but the password is more like an API that is very easy to implement. I mean, that's also why there are so many implementations and why Sony didn't encrypt their passwords, because that's not part of the API, it's just something you should do. So I was wondering if you're thinking of just taking some of the core ideas, such as the visual side channel and radio, as in this case, but essentially a network or high bandwidth channel that is indirect, as a sort of framework or concept, because I mean the Pico is probably going to be made in China with a backdoor and sold cheaply here anyway. So I mean, because the system, or parts of the system, could definitely be used today with a smartphone. And so where are you going with? Are you going with this as a sort of exercise in designing the Pico, or would you actually try to do work to actually try and replace passwords as a system?
Well,
you can do both.
I am trying to replace passwords, and especially the part of the password problem that are the most aggravating, and for that reason I have set as my zeroth principle that I want not to rely on users remembering things. And I said, what can I do for that? And I started building something. As I said, at least for intellectual honesty, I have to provide a system that is complete. So whenever I do something, I cannot say, well, and then someone else works out the details for that. So let's at least start from a design where all the bases are covered. But still, this is a fairly modular thing. I could have easily stopped at the point of saying, here's the Pico, and then so long as you don't lose the Pico, it's okay. Which is what, I mean, you could say RSA, secure ID token does that. You have the secure ID, it lets you authenticate to the thing, but so long as you don't lose it, or maybe it's protected by a PIN or whatever, and it's already addressed by, come back, give me a moment. So you could cut this Pico work in at least two parts. One that says this is how the Pico works, this is how it exchanges, how it does SSL-like things, and it doesn't do passwords anymore. And this is how you secure the Pico. You wanted to secure something else, be my guest. You want to use a PIN on that, I just look disgusting to me to do that. Yeah. So that is a kind of already two separate discussions. How to make the thing in a way that all these things, we could certainly split out several parts of what I did. The multi-channel protocols work that we did several years before wasn't related to that either. This is one way of saying, if we had no constraints of compatibility, is there a complete solution that we could roll out, which we would consider better? And I would consider this better, except for the management problem of the shares so far.
Yeah, I just want to say that it's 13 minutes until lunch.
Okay.
Of course, we can use a few additional extra minutes, but I'll make sure that Frank Stajano joins in for dinner, and those of you who would like to talk more to him, join in for dinner. It's that easy.
Right. So I'm very grateful for the interaction that you are offering, and this thing here says 24 out of 37. Now, I've already seen the slides, so I don't actually care. I mean, I'm much happier talking with you than seeing the other slides. If you want me to go through the other slides, I can do that. But if you prefer to keep asking questions, then
no, I think we should let you finish the presentation. I mean, some of the questions on backups, I think you were in the middle of talking about.
All right.
Kind of.
So.
Yeah. No more questions. Let him finish the presentation. Period.
So continuous authentication is a feature that I like about Pico, which is not often spoken about drawback of password authentication, where you're just authenticated at one point and then you have a window of vulnerability which is bigger the less you hassle the user. So it would be great if the authentication worked with telepathy, that as soon as you are not there, then you are not, it looks like you logged out. And as soon as you're back there, it looks like you log in again. So with Pico you can do that because you interact with radio, then you have a way of doing the check all the time without bothering the user with interaction. So the interaction is required at the beginning, like authentication session start, so that you can't have things like unlocking your account without your consent. But then once you are in there, so long as you're staying in there, you can keep on re-authenticating with sub-minute resolution if you want. So for practical implementation of this, and I must say there was a very nice paper that you should read if you're interested in this side of thing, continuous authentication, in Mobicom 2002, called Zero Interaction Authentication by Corner and Noble. And they had something where a token was used to encrypt, to unlock a full disk encryption on laptop, and as soon as you went away, then it would clear the cache and it would be locked, and as soon as you went back, it would re-decrypt the thing. And so things that would be interesting in the case of Pico, where you are using it, for example, for your login password and then your Gmail account kind of things, where there's a nested session inside that, would be how do you deal with those nested sessions? You need to also preserve state so that when you go away and come back, it's more a suspend resume than a log out, log in, because you wouldn't want to go away and go back and see that all your applications have disappeared because you have been logged out. So some of them are going to be inside other of them, and the nesting order might matter. And again, we have to beware relay attacks. If this is something where I don't give the consent after the first time, it could be that I could just be relayed somewhere else. Delegation and escrow is something that can be dealt with something that I mentioned earlier in the coercion slide, where you can decide to have more than one Pico holding different credentials, different grades of credentials. You can have things that are used for one purpose and things for a higher security purpose you don't bring when you go on a dangerous trip. So you could also do a partition along another dimension. You can say, I have my own private things on a Pico and my corporate things on another Pico, and this corporate Pico may be escrow. So there may be other, the company system administrator can have a special Pico siblings that unlock that one, but they still won't have access to my own personal things. So I could partition, air-gap, physically partition my credentials in this way by having several Picos. The fact of being able to register more Pico siblings and giving them to someone for escrow is something that may be useful even in the personal case for something like your digital testament. You don't want all your things to access your, for example, bank accounts and so on, to not be available to anybody if you just die. And so in that case, your biometric goes away. You might give your spouse enough Pico siblings to unlock your Pico in case of necessity, even though with the agreement that it's only used in case of death. And so this seems like a very versatile solution, and the only problem I see again is the practical one of this proliferation of tokens. If I start having several Picos, one for this purpose, one for private credential, one for public credential, one for work and so on, then I will not have the correct Pico with me the time I need it. So that flexible, but maybe can become too flexible. Another interesting thing that I think is perhaps one of the most intellectually stimulating aspects of this in the context of not just getting rid of web passwords, but all passwords. I have, in the paper I've been working, I spent a few pages on what are the other apps that are not web apps. There could be things like you log into your computer either locally or network system, or you go into your BIOS, or you go into the thing that locks your car stereo so it can't be stolen, or the thing for your burglar alarm, all things that are not web applications. So there are ways of dealing with that. But the most interesting one is one where there are passwords that are not used for authentication. So none of the above. And that's, when I look at file encryption, for example, it's fundamentally different from login with username and password, because with username and password, the app is a kind of gatekeeper that says, prove to me that you're authorized. If you're authorized, I open the gate and I let you in. With the encryption, it's not that. It's not that if you're authorized, I let you in. It's that I need those bits in order to do the decryption. So the password is something that is used for generating the key that actually decrypts the file. And without the password, there's no gatekeeper that can say, well, you're authorized, you're not authorized. I just need those bits. So I have tried fitting that into the mold of the username password kind of thing. See, if I could model this, the pairing and the main button with this, but who would be the app? Maybe the encryption program. Who would be the user ID? The file name didn't quite sound right. If I could encrypt the same file under different passwords if I wanted. So all of this is, I think, a different way of using passwords that should be treated appropriately. And it's not right to use the same SSL line, public key, and so on mechanism for generating a key. So this is, I think, should be dealt with differently. And in this case, the PICO should have some randomly generated bit stream that it sends off in the same way that it would send a password if it were a password wallet. So the interaction has to be different in this case. However, if I do this, then there's a problem with my promises of what the PICO will do. I said the PICO will not ask you to choose the right credentials for this, and it will not let you be phished. In this case, because there is no public key I can speak to, it will be possible for some malicious application to present me with a file and say, now give me the keys to decrypt that file. And I have to select the right key, and I can recognize the key for decrypting that file, but I have no assurance that I'm talking to the right application that I meant. And so that string could be stolen from me. Now, I've thought hard about this. If anybody wants to keep discussing this, I'd be delighted to have a chat about this. But I believe, I don't have a proof, but I believe that there's nothing theoretically that could be done to stop someone stealing the key in this case. How can I avoid, how can I recognize that I'm not the victim of some man in the middle that is asking me for the password? So this is a difficult to read slide, but perhaps the most important. And I have listed here various ways of replacing passwords and doing that in passwords. And I have listed here the minimum principles, the 0 point something. Here are the ones that PICO promises to do. And here are the things that PICO doesn't actually worry about. So as cheap to deploy passwords and no changes to the servers. Now this part is out of date in the paper. I'm still adding more related work. And in this last column, what I say is has been built, because it's unfair to compare features of something that, I do all these things, I don't actually exist. So these things have been built. These things are just academic papers. These things that have been built are publicly available, because some of these are academic papers, have been built, but nobody's using them, or have been built, are not even published. And some of these widely deployed, so have been built and actually people use that a lot. So there's no time to go through every square of this slide, but it's interesting to do a comparison with the previous stuff. And in fact, the one that is most interesting here, especially for filling those parts here, is the single sign-on. So single sign-on is a completely different approach to getting rid of passwords, but it offers many of these benefits. And I guess a notable exception here is that does it replace all passwords, or just the web ones, or just the online ones? And this is something that single sign-on cannot do. So, compromises to reach critical mass. Well, this is my academic ancestor. Roger Needham was the PhD supervisor of my PhD supervisor. And he said, optimization is the process of taking something that works and replacing it with something that almost works, but costs less. So in that spirit, we might consider optimizing the design of the Pico, turning it into something that costs less and almost works. And one of these things could be to implement it on a smartphone. And the almost works refers to the fact that the operating system of the smartphone may leak the credentials in a number of ways. Another thing would be, okay, if we just want to be compatible with what exists today, so that there's a chance that this will be adopted, instead of doing all this public key business, just have the Pico store your passwords and spit out the passwords into the application. So at least the backends don't have to be changed, because if you have to change the backends, who's ever going to change the backends? As we said earlier, we could replace all this Pico siblings business with just a master password or a PIN that you type to unlock your Pico, which of course defeats the first requirement that I started with, but some may think, well, it just saves me so much headache that it may be a good place to start. So this last section here is the grand plan for world liberation from passwords. And I mean, there's not much serious stuff here. It's mostly a plan, but you know, first you have to build one that can withstand an adversarial review. Then once you have something that you can try out, you have to give it to users and see if they can actually make it work. Is it any better than passwords? Otherwise, there's no point going any further. And then at that point is the time to redesign and re-engineer it. And then for building it into critical mass, you have to give in on some things. You have to
Convince Facebook.
yeah, so you have to make things that, even though they are optimizations in the Roger Needham sense, let you have a foothold. And then after that, you can build on this. And once you get to the point where the login pages look like this one here, where there's the user ID and password, and next to it, the facilities to use Pico, then you're happy, because everyone who has a Pico can still get all the benefits of it, and everyone who doesn't have can still use the thing as before. And gradually you see the populations change in percentage, hopefully. But that's a stage where you're not fighting for acceptance anymore, because every provider, every app will be happy to just support both if enough people have it. And eventually you get to no more passwords. So, my conclusions are that passwords are now beyond their sell-by date. So many of us have said that in the past few years, and so many of us have tried to provide some replacements. Now, you may consider this a very complicated way of replacing passwords. I might agree with you. But even though it's going to be difficult to tackle the backwards compatibility problem, we have a duty to think of something better than passwords for our users. And I believe that the things I said in opening, all these complaints about hating passwords are well justified when you see how unreasonable the aggregate constraints we put on users are. So I think this is the first proposal to eliminate passwords everywhere, not just from web or online sites. And this is the end of this, and the paper is in draft somewhere on Light Blue Touch Paper blog. I'm still working on this draft. I was writing new stuff even on the plane to here. I will certainly be writing more stuff after all we said today and after future interactions. We have maybe a dinner. And if you're interested in doing any more with this, talk to me. I have explicitly decided not to patent any aspect of this. This is all going to be royalty free. You want to build it and become rich, be my guest, just sign the paper. Thank you very much.